is of how much? 400 meters. Now you started from here, and you ended over here. So this is the total distance covered. And what is the total distance covered? 400 meter, because one lap is equal to 400 meter. This is the distance. So in one lap, you have covered the distance of 400 meter. It's sort of a relay race. Remember, relay race or a individual event race. Now, displacement. Say, read better.
Displacement, it is the length of shortest path traveling by a body
Traveled.
traveled by a from its interior portion to its
Initial
final initial portion to its final portion.
position. Okay. Now, what is displacement? Displacement is the shortest path from the, and what is the difference from the initial position to the final position? Look over here. This is the initial position. Yes, you started, and this is also the final position. You ended over here. So, what is the displacement? Final minus initial. What is the displacement beta? 0. What is the displacement over here? It is 0 meter. Have you understood? This is what I taught you yesterday. Okay, but with the diagrams over here, I'm teaching it again. So you start over here, okay, and you come back. So starting and the ending point is the same. So if starting is the point is a 0, ending point is also the 0. Fine. Now, what is the relation between the distance and the displacement? Yes, please read.
Distance is the length of path or path length traveling by a body.
Traveled better. It is not traveling. It is traveled.
Traveled by a body while moving from
Initial
initial portion to a final portion
position.
position.
Okay, thank you. So now distance is what? Is the complete length of the path which a body travels when it is moving from initial to a final position, right? That is the complete length of the path. Second para,
It is a scalar quantity.
scalar.
Scalar quantity. Its SI unit is meter. Here only a magnitude is important, not the direction
Okay,
of movement. Implies that the length firm length can never be negative.
yes, good. So it is a scalar quantity. Okay, so what is important? Only magnitude is important. Direction is not that important. Only how much you have traveled, 2 meter, 5 meter, 100 meter, 1 kilometer. So that number is important. So hence it is a scalar quantity. But remember, the direction is not important. So only number is important, only magnitude is important and not the direction. You understood now? Okay. What about displacement? Say,
Displacement is the shortest distance between the initial and final portion of the body.
so what is displacement? Regardless of distance, distance is complete distance which a body travels on a path, on a given path. Whereas displacement is the shortest distance between the initial and the final position of the body. Yes.
It is
Yes,
a
continue. Vector.
quantity.
Vector.
Vector quantity. Its SI unit is also meter. In displacement, the direction of a motion is always directed from the initial portion downward the final portion.
Toward. Toward the final
Towards the
question. Fine.
final
Thank
portion.
you. So, distance is a scalar quantity where only number is involved, whereas displacement is a vector quantity. Why? Because the direction of motion is taken for granted. The direction of motion is important over here. And where is the direction of motion going? From the initial position towards the final position. So here the direction is also involved. So hence it is also called as vector quantity. So I hope you have understood the difference between the distance and displacement. Yes, children? Hasnain, Siptain, have you understood? Hello? Have you understood all of you better? The difference between distance and displacement? Okay. Now next is speed. So we are through distance, we are through displacement. Now we come to speed. So what is speed? Yes, read better. Read better.
Speed. Speed of a body is the distance traveled by the body in unit time.
So
Speed
speed is what? The distance per time. Distance per time. Per means division. Okay. Whenever I use the word per, distance over the by the body in unit time or unit time. If I say per unit time or unit time, that means we are dividing. Always remember that. In the definition itself, you can have the formula. Okay, so I'm giving you the hints. So it's the speed of a body is actually distance. So d. Distance is d divided by t. Or you can even write as distance upon time. Okay, fine. So how do you relate? Say better.
if a body travels a distance in a time, then its speed is
Equal to
v is equal h upon 2
tt. This t better.
t. The SI unit of speed is meter per second meter.
Meter
S
per second.
or meter per
Either you
second.
write it meter per second or you write meter per second or you write meter second inverse. Read it again.
The SI unit of speed is meter per second.
Again it's meter per second. You have to
Per
m
second.
divided yes. Or meter
Or
second
meter
inverse.
second
Second inverse.
inverse. Since speed has only magnitude, it is a scalar quantity.
So speed has got only number. The direction is not important, so it is a scalar quantity. So this is how you have to remember all these aspects of motion. So we are through distance, then we did displacement, and just now we finished speed. Now speed is equal to s upon t or distance upon time. The unit is meter per second or meter second inverse, and it is a scalar quantity. Now distance is a scalar quantity. Displacement is a vector quantity. Speed is a scalar quantity. This is how you have to remember. Okay? Again, we will revise regarding the speed. Just go through point by point beta. Yes. Read better.
Speed. Rate of change of distance is called speed.
What is average speed?
Average speed is the ratio of total distance and total time taken.
So what is the meaning of ratio? That means it should be total distance upon total time, isn't it? This is the formula of average speed. Total distance upon total time is equal to average speed. Yes. Next point.
Speed is equal to distance plus time.
It is not plus
Divide
by
the
time. It is divided by time.
divide time.
Good.
Speed is a
Then
scalar quantity, so it has only a magnitude, a number and unit, and does not include direction.
that we have already studied. Okay. Now we will come to another type of speed that is called as instantaneous speed. What it is? Instantaneous speed. Read.
Instantaneous speed is the speed at a specific instant in time.
Okay. That means I want to ask you, okay, just give me the speed right now. So that will be instantaneous speed. You understood? At that particular moment, I want the speed of your vehicle. That will be taken as instantaneous speed. And if I want, okay, give me the average of your vehicle, then what you have to do, you have to travel miles together, kilometers together, then you have to make the average of it, and then you have to let me know. That will not be instantaneous speed. Hope you understood the difference between instantaneous speed and the average speed. Yes? Have you understood the difference between instantaneous and the average speed? Instantaneous speed will be taken at that particular moment, whereas the average speed will be taken for a long period of time. Okay, that's the difference. Yes, let's do it again.
Speed is defined as the rate of distance covered by a body. Mathematical speed is given as speed is equal to distance upon time.
Please adjust your mic. There's some sort of disturbance coming.
A
Okay,
body
start.
traveling a body traveling from a one location to other might stop, slow down, speed up, or move at a constant speed.
Speed.
Speed. The average speed of a body is defined as the total distance traveling divided by the total time taken.
Hmm.
Mathematical average speed is given as average speed is equal to total
Total
distance upon
distance.
total time.
So I hope you have understood now. This speed is distance upon time, whereas average speed is equal to total distance upon total time. So this is how you have to tally. You have to differentiate. So speed, distance upon time will be instantaneous. Average speed is total distance upon total time. It takes from one location to another location. It can stop, your vehicle can slow down, it can accelerate, or it can go at a constant speed. That time we have to take the average speed. Is it clear? Like we go on the highway, we go from here to Ahmedabad. That time we find the average speed. Okay? But when you are traveling in Bhavnagar, you're getting my point? And just a few distance away from your home, you're going to a shop, that time we will not be taking the average speed. Remember that. That will be just a simple speed we'll be working on. Now we come to the fourth
Velocity.
factor of motion, that is velocity. So we are through, again I repeat, distance, displacement, speed, and now we are going to work on velocity. So these three are clear to you? What have we studied so far? Is it clear to you, boys? Have you understood whatever we taught just now?
Yes, ma'am.
Okay. Now, if at all you're stuck somewhere, you're not able to follow, you can stop me right away. Okay? Okay. Siptin, would you like to read? Hello? Siptin, would you like to read the slide? Hello? Okay, carry on better. Velocity.
The rate of motion of a body is more meaningful if a
Specify.
specify its direction of motion along with speed. The quantity which specifies about the direction of
Both.
motion,
It's not about beta, it's both.
both the direction of a motion and speed is velocity.
Okay. So what is velocity? It is showing both the direction of motion and also showing the speed. That is called velocity. So velocity is showing the speed with the direction. So it is what sort of quantity? What sort of quantity beta? It is a vector quantity. Velocity is a vector quantity because direction is also involved. You understood now? It has got magnitude as well as direction. It's got a number as well as direction. So it is a vector quantity. So velocity is a vector quantity. Okay. What is the definition of velocity, by the way? Yes.
Velocity of a body is the displacement of a body per
Then
unit time.
fine.
Velocity
So
is
understood. So what is velocity? It is the displacement of the body per unit time. Whenever I say per unit time, that means I have to divide it. Okay. What I have to do? I have to divide it. So what is the formula? Yes. What is the formula, beta? Hello. What is the formula? Velocity is equal to
velocity is equal to displacement upon time taken.
good. And what is written?
Since velocity has both magnitude and direction, it is a vector quantity.
It is a vector quantity. So I just said the same thing has been repeated. It has got both magnitude as well as direction. So it is a vector quantity. So what is the formula of velocity? It's not distance, remember. Velocity is called displacement upon time taken. So you have to learn all these formulae. Okay? First you have to understand and learn all these formulae. So any problem regarding velocity, beta? Yes? Is there any problem regarding velocity? Boys,
No,
okay,
ma'am.
I take it. Okay, fine. I take it then that you know everything. Again, we do the same thing. If I take another slide, that means it's giving you something extra, and then you have to tell me what extra you got in this slide. Okay? Yes, read better. If anyone wishes to read, you can let me know, please. I wish that all of you get the chance to read this slide. Okay? So you're welcome. All of you are welcome to read this slide. Yes, better start.
Can we include the direction of a motion with speed? We are talking of the
Hello? Hello? I can't hear you better. Can anyone start reading better? Or there must be some internet problem in his place. So can someone start reading? Arman, can you start reading better? Hello?
Velocity.
Hmm. Start.
Velocity.
Hmm.
When we include the direction of motion with speed, we are talking of this physical quantity called velocity.
Okay.
Thus, velocity is speed with direction. Velocity is defined as the rate of change of displacement. It
Okay.
is a vector quantity.
Put off your
Therefore,
mic. Please put off your mic. Thank you. Yes. Continue better.
therefore, direction of movement is important. Implies that velocity contains algebraic sign.
Okay. Now what is the algebraic sign? Plus or minus, right? That is what algebraic sign. So when the direction of motion is included along with speed, so that becomes velocity. So velocity is what? It's actually speed, isn't it? Velocity is what? Speed, but with direction. So what we say, it is a displacement. So rate of change is displacement. It's got both the quantity, that is, it's got both the thing, magnitude as well as um, direction. So it is a vector quantity. Formula wise, velocity is equal to displacement upon time interval. Let's do this. Start. Start with that.
Average velocity.
No, no, a
Any
body moving. A body moving.
okay. A body moving from one point to another may change its velocity. its velocity a number of times, but it will have an average velocity of its journey. Average velocity of a body is defined as the net displacement divided by the total time of travel. It is a vector quantity. It is SI unit.
Speaking, there are someone who is speaking to stop speaking with it. Thank you. Yeah, start.
This SI unit is ms and it can be
Meter
positive,
per second.
negative.
It is not ms, it is meter per second.
Meter per second, and it can be positive, negative, or zero.
Okay. What is average velocity formula wise? Yes, hello. Average
Average
velocity is equal to
average velocity is equal to initial plus final velocity upon a period of time.
that is total of time, right? Total time. Fine. So when you see the average velocity is what? It's moving from here. For example, it's moving from here and it's at a uniform speed and then it stops. Then it speeds up. Then it slows down. Okay? Then the tire gets punctured. Then we repair it. Again we start. Again we stop. And then we finally reach the destination. So this journey, I cannot have the velocity as such. So what I have to take? I have to take average velocity because the speed changed during the journey. So that time we take average velocity. So the net displacement is from here to here. And how much time did we take? That is the period of time, the total time. That time we have to take average velocity. If I'm going from here to Ahmedabad or Baroda or Delhi or Mumbai, what I will be taking? I will be taking the average velocity. What is a unit? It is meter per second. Why? Because velocity is equal to, what is velocity, beta? What is velocity? Displacement. So what is displacement? What is the unit? Meter. What is unit of time? Second. So it is meter per second. Understood? Boys, did you understand? Yeah? So this was all sort of division of velocity and average velocity. Now we come, again I repeat, what have we done so far? Distance, displacement, speed, velocity. Now we are going to do acceleration. Is velocity okay with you? Have you understood what is velocity? Boys, I'm asking you. Everything is related with it. Now, acceleration is going to be related to velocity. So if you understand velocity, then only you will understand acceleration. Okay? Yes, start. Yes, read better. Hello? Start reading. Yes, Salman, can you?
The quantity which a specify change in a velocity is
There's disturbance better. See to it. Yeah, now it's okay. Yes, read it again.
the quantity which a specify the change in velocity is
Acceleration.
acceleration.
Okay, so what is
Acceleration
acceleration? Change in velocity. As simple as that. What is acceleration, beta? Change in velocity. Isn't it? That is called acceleration. In other words, how do we define? Let's see. Yes, start.
it is the change in a velocity of a body per unit time or
Yeah,
the rate change of a velocity.
fine. So acceleration is change in velocity divided by time. Isn't it? That's not a change in velocity. So whenever we are doing anything about change, it has to be divided by time. Always. Everything is, the reference is time. So change in velocity per unit time is acceleration. How do we give the formula of acceleration? Let's see. Start better.
Change in velocity upon time.
Read.
If the velocity of a body change from initial value of u to final a value v
V.
in a time, then
T. T.
acceleration
T. In time T.
time t, then
Acceleration
acceleration a is equal to v minus u
upon
upon
T.
t.
You can see over T. The T has gone down. It should be over here. So A is equal to V minus U upon T. Now this is the formula of acceleration. What is V? Final. What is U? Initial. Understood? You have to remember all this. So initial is U, final is V. So obviously the bigger will be the final one. Obviously, so V I have to take it in the beginning so that acceleration will never be negative. Now what is the unit of acceleration, beta? What is the unit?
The, the SI unit of acceleration is
Ms minus 2.
ms minus 2.
Or you can write meter per second square. What you will say? meter per second. I can write it like this as well, isn't it? What I will write? The unit of acceleration is meter per second square. Okay? Okay? All this formula you have to remember to do the numericals. Okay, beta? I hope you have understood all the features of motion, starting from distance, displacement, then we came to speed, then velocity, and we finished the acceleration as well. Okay? I think we can take up this also. Just read it better. It's just a revision. Can you do this? Just read it better. Read it better. Hello? Please read it. Can you hear me better? Arman, can you take up?
Yes, ma'am.
Yeah, please read it.
Acceleration. Acceleration is defined as the rate of change of velocity. It is a vector quantity and its direction is given by the direction of the force causing the acceleration.
Okay, so direction is
Mathematically,
important. Yeah.
mathematically
Mathematically,
acceleration is given as acceleration is equal to change in velocity time taken
upon time taken. Should
upon
read like
time.
that. Yeah. Now,
Okay. Suppose the velocity of a car is u at time t. Later
T1. T1.
t1. Later at time t2. Its velocity becomes v.
Hmm.
Change in velocity is equal to v minus u
You agree?
time. Yeah.
V is final and U is initial, right?
Yeah.
Then,
Time interval is equal to t2 minus t1.
okay. So it is the
That,
final time and this is the initial time. So what is acceleration?
therefore, acceleration is equal to v minus u upon t2 minus t1.
And what otherwise in other slide what we had seen? We had seen V minus U upon T, isn't it?
Yes.
Now it is T has been changed into final minus initial. So it becomes T2 minus T1. So that's the reason that I've taken this slide. Okay. So it need not be only T, it could be the difference of the time as well. The final time minus initial time. I hope you have understood regarding the acceleration.
Yes, ma'am.
Yeah. Okay. So we come to a close this lecture. Uh, we have come to close of this lecture. So we meet tomorrow or maybe on Monday. So I wish before we begin with a new topic, altogether new topic, I wish all of